Hey guys, all right, let's look at scientific notation. Okay, so scientific notation trips people up an awful lot, um, and not necessarily for any really good reason, right? In that uh, when we look at it, it tends to look really hard at first, but if you know what to do with it, it's not really that bad. So let's go over how we do these. All right, so we're gonna do. I think we have like 6 different examples here. Okay, so we'll start here with 6.7. So we have 6.7 times 10 to the third. Okay, so here's the rule. So 6.7 times 10 to the third, how do we figure that out? Okay, so we have our 6.7, and the rule is for every one of these exponents, we're going 1 decimal to the right. Okay, assuming the exponent is positive, we'll deal with the negative exponents here in a second. Okay, so that would mean we're going 3 spots to the right, like 1, 2, 3, right? And so for the places where there's no numbers to the right, we'll just throw a 0 on there, like there, and then the decimal point would be like right here, right? And then it would be like, so it'd be 6700.0 or just 6700, right? And that's our answer, right? 6.7 times 10 to the third, 6700, right? So that wasn't too bad, right? It's just remembering or learning that little rule about going to the right. Okay, now let's look at a negative one. And we'll go back to some positive examples so you can see a few of these. Which a lot of times that's the key in math, is seeing like a few different examples where we change the numbers up, but are really tending to do like pretty similar things. Okay, so 6.7 times 10 to the negative 3. Okay, so when we look at that, we tend to be like 10 to the negative 3. I have no idea what that number is. And you don't have to know, right? So again, we have our 6.7. Okay, so this time when it's negative, like when it was positive, we went 3 spots to the right, yeah? Here we're going to go 3 spots to the left, right? So we go like 1, 2, 3. Okay, and again, there's 2 zeros, and then decimal point right here. Okay, and that would be our answer, is 0.0067. That's all you got to do, right? We'll look at a few other examples, but that's really the whole concept right there. So that's all you got to know. So you just do that, take your time with it, and you're good. Okay, so what if you saw 67 million? Wait a second to write this guy out. Okay. And they said put that in scientific notation. Okay, and obviously it's going to be multiple choice, so we'll have a few answer choices. How do you do that? Okay, so usually we're going to go back to our 6.7, right? Because almost for sure all the answer choices are going to be like 6.7 times 10 to the something. So we'll write that part out too. 6.7 times 10 and then some number, right? Okay, so all we're going to do here is we're going to start right here at the end, and we're just going to count how many spots we have to go until we get to the place in between the 6 and the 7, right? So it'd be like 1, 2, 3, 4, 5, 6, 7, right here. Okay, so 10 to the 7th, right? That's all you gotta do. We're done. Done with that question. 6.7 times 10 to the 7th. You could write it different ways, but that's going to be the answer that you're given. 6.7 times 10 to the 7th is correct. Okay, so what if we were looking at 67,000? Okay, and again, you would be looking at 6.7 times 10 to the what? Okay, so again, here's our starting point right at the end when we see the bigger numbers, right? And then we're just going to where the 6 and the 7 are separated. 1, 2, 3, 4, right there. 6.7 times 10 to the 4th. Okay, so as you're looking at these, you're like, like while it looks like it's one of the harder things when we first look at it, is really like this doesn't really require a whole lot of math skills, right? It's just knowing go to the right, go to the left, how many spots, count them out. It's pretty much it. Right? That's what you need to know for scientific notation. So we're going to do two more still, though, right? Just to give you two more examples. Okay, so what if it's this one? We do with this guy. 0.0006 okay, and they want that in scientific notation. Okay, so again, like all your answer choices are almost for sure going to be 6.7 times 10 to the something. Okay, so when you see a number that's less than 1, like here 0.00067 is definitely less than 1, then we know this 10 is going to be times 10 to the negative something. So if there's any positive answers, you can at least cross those off, and then you don't even have to know anything else. So you can at least eliminate some answers, give yourself a better chance. But we like to get it right. Okay, and so on this one, we'll still start here until we get, again, in between the 6 and the 7, right? So 1, 2, 3, 4. There we are between the 6 and the 7. There's 4 numbers. It's going to be a negative. 6.7 times 10 to the negative 4. Okay, and one last one, because what if they multiply them together? 6.7 times 10 to the 5th. What does that equal? Okay, and so if you look at that and you're not sure, okay, so we've got our 6.7, right? And then we're thinking, let's see, so as we start here, 6.7, as I look at that, I will go 5 spots, right? So 1, and then there will be 4 more, yes? So let me throw on 4 zeros. Okay, there's that. There's that. Pretend there was never a decimal place. And 670,000 will be our answer for 6.7 times 10 to the 5th, right? So all I did is I started in between the 6 and the 7, right? And then I just went 5 spots to the right, right? So the first one was just the 7, the other 4 were the zeros, and then I put the comma where it was supposed to be, and we got 670,000.